Hi guys, welcome back. Today we're going to be going over heat and how and why it's even important, okay? Specifically, we'll be looking at an exothermic reaction today and why heat matters. So let's start with that big vocabulary word here, okay? Before I begin, please remember that the directions were for you to take notes as you go along, okay? So be sure you're taking your notes. We'll be looking at an exothermic reaction, okay? So first we need to break down this word, exothermic. Exo means out, okay? So in this reaction, something is going to come out. While therm, okay, means heat. So that way we know something in this reaction is going to come out and something is going to have to deal with heat, okay? This is how we write it chemically. We're going to be adding calcium chloride with water. These show you just what the molecules look like, okay? You do not need to write this down. This is just so you can be ready for it next year as 8th graders. So I'm going to go ahead and play this video of me doing the exothermic reaction. Be sure that you are taking notes as we go along on really important things that you hear. Hi guys, welcome. This is our first lab for 7th grade science with me, Miss Flowers, okay? Before I begin, I want to go over how I'm following lab safety and protecting myself. We are using chemicals today, so I have gloves to protect my hands. I have a lab coat to protect my clothes. I am wearing goggles on top of my glasses because I really want to protect my eyes. My hair is up and out of the way so it will not fall into the experiment I'm doing. Lastly, there is no food or drinks over here and I'm not chewing gum, okay? These are the lab safety precautions that I'm following. Now, the lab we are focusing on is we are adding calcium chloride with water, okay? As you saw in that presentation, this is an exothermic reaction. So like you just saw, exo means out. So I know something is coming out. Therm means heat. So I know something in here has to do with heat, okay? I want you to brainstorm an idea. What do you think it means for it to be exothermic? Something's going to come out and something has to do with heat, okay? What we're going to be adding, like I said, is the calcium chloride with water. We are going to be using this beaker to complete our experiment in. I know I have something to do with heat, so I have a thermometer to measure temperature. I have my water right here. It is already measured out for me. And lastly, I do have the calcium chloride right here. We are going to first start by adding the calcium chloride to our beaker. I'm going to keep the beaker on the table. I want to be sure that I'm holding the bottle away from my face and that my head is not over top of the chemicals. I'm going to use a tool to take the calcium chloride out of the container and into our beaker. I want to immediately put the lid back on my chemicals to protect them from the air. I'm going to set this aside. Next, I've already measured out all my water, and I know that I'm taking calcium chloride and water, and the plus side tells me I'm mixing them. I'm adding them together. I'm going to take the calcium chloride that is in this beaker, and I'm going to add my water. I already took a temperature of what the water was when I added it, and when I added the water, it was 73 degrees. That is considered room temperature, just regular water. Here, I'm going to put the thermometer inside so that the bottom of the thermometer is covered by my mixture. Already, I can feel the heat, and my thermometer, as you can see, is at about 115 degrees. It has been less than a minute, and we've already gone up from 73 to 115 degrees. As I sit here and I wait a little longer, I can see that the temperature is still rising. I have to be careful and I'm not touching the bottom where the liquid is because it's hot. I don't want to burn myself. I can see here, looks to be about 120 degrees. What do you think? Can you see that red line? It's a little over 120. And guys, this is a small amount, so it's not going to last very long, but notice how fast that temperature went up. It looks like the temperature is still going. You can see it's getting closer to that 130 mark. We're at about 125 now. So with it being at 125 degrees, I can now kind of tell that it's starting to slow down, meaning the reaction is almost over. Again, that's because we're using a very small amount, okay? I'm going to put this safely to the side, and now I want to think. I know that this was an exothermic reaction. Something came out, and there was heat involved. I also noticed that the temperature went from 73 degrees up to 125 degrees. So I want to think. When I mixed the calcium chloride with the water, what did that equal? Oh, you're right. It made heat. We were able to feel that heat, which is why we call it an exothermic, because the heat came out enough that we could feel it, okay? Not all heat can be felt, but this was hot enough that we could. That makes it an exothermic reaction, okay? I want you guys to continue going through that presentation to keep learning more. Okay, guys, sweet. So let's go a little bit in depth of what we just learned, okay? You heard me say a lot that was an exothermic reaction. I really want to focus on this word here, therm, okay? So let's focus on the exotherm part. What does therm mean? I know we talked earlier that it means heat, but have you ever seen that word before? Or has it ever been inside of a word before? Let's look at a couple of examples that we might remember, okay? We might have heard of geothermal, how there's geothermal heat from our earth. You've probably heard the word thermos, how it keeps your drinks hot or it keeps them cold. So it's either keeping the heat in or it's keeping the heat out. You might have heard of a thermal spring. These are really cool. Up in like Iceland and Greenland, they have these. They're like natural hot tubs, and they are hot. They are thermal spring from the Earth's heat. You've all heard of a thermometer. It measures heat. Ooh, and in your house, you probably have a thermostat to control heat. Okay? So I want you to get real comfortable with this word therm. Maybe it's important to write it down too, that therm means heat. That might come in handy later. So I want to focus on bringing this concept back. So we looked at an exothermic reaction with chemicals, but let's focus on how it relates to us in science. For a moment, I want to remind you, humans are animals too, okay? So keep that in your head. I want to focus, where does energy go? So let's look at this here to understand. We know that we take in energy from eating. We take in 100% of that energy from what we eat. That's how we get energy, okay? 25% of our energy is stored in our tissue. This is also like how we have fat in our bodies. That's stored energy. We use it for later. Now let's focus on how we lose energy. 25% of your energy is lost through respiration. Have you ever noticed that your breath is hot? You can feel that heat coming out of your body. 40% of our energy is lost from body heat. We are warm-blooded animals like other mammals, okay? We lose heat by keeping ourselves warm. That's how we regulate our body temperature. Now, other animals like reptiles, okay, like snakes, they are what's called cold-blooded because they cannot do this. They can't control their body temperature with heat. That's why snakes curl up and you find them under things like logs or trees, is because they're trying to hold in that heat because they cannot make body heat like mammals. But it takes a lot of energy to make body heat, which is why we lose 40% of our energy that way. The last part we're going to focus on for heat, we got to talk about it, guys, is excretion. Okay? Whenever your body gets rid of waste, this includes farts and poop, we lose 10% of our energy there. Now, I know it's silly, but I want you to think. Did you ever wonder why it's warm whenever your body gets rid of waste? We're actually losing that 10% of energy in that way because of how the heat is lost in our body, okay? Something I want you to remember, a very important thing. We lose energy in multiple ways, okay? But we can only take in energy in one way, by eating. So what I need you to remember and write in your notes is this saying that we eat for heat, okay? Without eating, we would not have energy, meaning we would not have heat, okay? We have to eat in order to continue these processes. Does that make sense? Perfect. I want you to go ahead and make sure this is in your notes and keep going on with your activity.